Hey guys, I want to go ahead and do a couple of problems on synthetic division. We've gone over polynomial long division, and the main difference is, well, synthetic division is a little bit faster, but the only thing with synthetic division, it has to be a binomial. When you divide, you have to divide by a binomial, okay? So the key is you must divide by a binomial. Okay, and the reason being is because x plus 2, you're going to go ahead and actually solve it. Kind of like when you do the zero product property, x plus 2 equals 0, therefore x is equal to negative 2. Okay, so this x equals negative 2 is what you're going to be using to divide this polynomial. So what you do is you get that negative 2. Okay, you're going to house it. Some professors do a little bit differently, but this is the way I'm used to doing it, and it's comfortable for me. And then we're going to go ahead and take the coefficients of each of these terms. And remember, it's got to be in descending order. So this is x cubed, x squared, x, and the constant. So we start off with 3. And then we have plus 2, positive, and then 1. And then we have the constant, which is negative 2. Okay, and all you want to do is just bring the first guy down, which is a 3, multiply, negative 2 times 3 is negative 6, and then just do what this tells you. Negative 2 minus 6, well, that's going to give me negative 4, multiply that, that's going to give me 8, 1 and 8 is going to give me 9, negative 2 times 9 is negative 18, put that together, that's going to give you negative 20. Okay, and this guy would be your remainder. Okay, now when you go ahead and rewrite this guy, instead of it being 3x cubed, it's now becomes an x squared. So the answer to this guy would be 3x squared minus 4x plus 9. That's a minus 20 divided by, this is our remainder, so this is what we were dividing by, x plus 2. Okay, and that is it, guys. That would be it. Now the reason, guys, we go ahead and do synthetic division is because we want to, it's a type of factoring. Because see, eventually we're going to go ahead and be graphing these, but I have to factor it. I have to break it down into its parts. And this becomes kind of difficult because I don't know how to factor this something x cubed. Sometimes I can go ahead and, maybe factor out an x, or maybe do factor by grouping, but not in this case. Okay, so we use synthetic division or long division to go ahead and factor it. Sometimes the professor will give you something kind of like this. Now 2x minus 1, we have to go ahead and solve it. So 2x minus 1 equals to 0. When you solve it, x equals 1/2. Now the only problem is it is a fraction. It is a pain in the butt, but we can go ahead and do that. So still use 1/2, and we just go ahead and do the same thing we did before. We go ahead and use 2, then the x squared is 3, negative 8, and then the positive 3. Alright, and bring down the first guy, which is 2. Half of 2, well, that's 1. 3 plus 1 is 4. Half of 4, half times 4 is 2. Negative 8 negative 8 plus 2 is negative 6. Half of negative 6 is negative 3. And actually that becomes 0. So that means that this guy is a factor. So how would I write that? Well, I would write it x minus 1/2. Okay, parentheses. Now this guy would become 2x. Instead of cubic, it's a square. 2x squared plus 4x minus 6. And then since the remainder is 0, you don't need it. Now this one, x minus 1/2, is the same thing as 2x minus 1. Okay, I just kind of brought it back down. So 2x minus 1, same thing. Okay, now for this guy, this is a quadratic. I can go ahead and factor this guy. Let's go ahead and take out a 2, factor out a 2. So we're left with, what is that, x squared plus 2x minus 3. And this guy actually can factor even further. So let's see here, that's a 2. Let me put this 2 out in the front, x minus 1. And this guy, when you factor him out, you should get, what is that, x plus 3 and x minus 1. Okay, and this is important because when we start graphing polynomials, these guys now become the roots. Okay, these are the x-intercepts. So the x-intercepts, or the roots that we call them, are x equals 1/2, x equals -3, x equals +1. And that's important because now, knowing the roots, we can go ahead and graph this polynomial. And we'll be doing that later on. Alright, let's go ahead and do the next one. As you can see, I don't know how to factor this guys to the 4th power. So, but I do know it's a binomial, so I'm going to go ahead and divide him. So, let's go ahead and do it down here. X plus 2, when I solve him, he becomes -2. X to the 4th, there's a coefficient of 1. 1 in front of the x cubed, -7, -13, and then -6. Okay, bring down that 1. -2 times 1 is -2. 1 minus 2 is -1. -2 times -1 is +2. -7 and plus 2 is -5. -2 times -5 is 10. And you notice I'm just kind of doing whatever this tells me here. -13 and 10 positives, well, that's -3. Negative times negative, that's a +6. And what would you know? It cancels out. So this tells me that this guy's a factor. So x plus 2 is a factor. And then when I rewrite this guy, I don't start with x to the 4th. I start with x to the cube. Minus x squared minus 5x. And then that's a -3. Okay. Now this becomes very interesting because, well, how do you factor this guy out? I can't factor that guy out. Well, it so happens now we have another polynomial, just kind of like this one. We do synthetic division again. The only problem now is we got to figure out, well, what are we going to divide by? Are we going to divide by x plus 2 again, or x minus 1? Okay, and what you do is, it's called the rational roots theorem. Okay, and what you do is you take the factors of this guy over here. Sometimes your professor will call it P, and then this guy's Q. So factors of this guy are plus or minus 1, plus or minus 3, and that's it. 1 times 3 is 1 times -3 is -3. -1 times +3 is -3. So we want the factors of this guy right here. Okay, now what about this guy? Well, that guy makes it easy. That guy would be plus or minus 1. So what we do is we take these guys over here in the end and divide them, the rational part, by the factors of the leading coefficient over here. So sometimes your professors will call it P over Q. So 1 divided by 1 is 1, and then 3 divided by 1 is 3. Well, that's pretty easy. Since I already know the answer to this guy, I'm just going to go ahead and use 1. Okay. And actually, I believe it's -1. So let's double check that if I'm right. So we go ahead and do the same thing. 1, use -1, use -5, and then -3. Okay, bring down the 1. -1 times 1 is -1. That gives you here -2. -2 times -1 is positive. -5 and 2 is going to give you -3. Negative, that's a positive. Oh, what do you know? It cancels out. So this guy, -1, actually becomes x plus 1. And now we have, well, the one before was what? -2, right? It was the x plus 2. So let's go ahead and put that there. And now it went from a 4th to a 3rd to a power to a quadratic. Power of 2. -2x minus 3. And you know what? Can I factor this? Yep, you can. So it becomes x plus 2, x plus 1, this guy becomes x minus 3 times x plus 1, and these would all be your roots. Now if you notice that x plus 1, I can go ahead and just write it together and put it as a power of 2 squared, x minus 3, and that's it. And that becomes important because now I have the roots, they're factorable, and I can go ahead and just label them on my graph and factor it. So guys, whenever you have these complicated ones, you start off with synthetic division, but then if you want to keep going, just go ahead and use the rational roots theorem. You take the factors of this -3 divided by the factors of the leading one here. Now this one was pretty easy. Sometimes they can get long and tedious, but that's a general rule of it. And honestly, a lot of times it's just you're using very small numbers, the 1 or the 2 or a 3. You rarely see like a 10 or a 7 up here. Okay, so hopefully that helps, and see you guys next time.